When we talk about rate of change, the rate of change can be constant or not. When you have a constant rate of change, that means that regardless of which set of points you're looking at on your graph or in your set of data points, the rate of change will be consistent, creating a linear relationship, which means it'll form a straight line when graphed. You have a line when graphed. If you have a rate of change that's not constant, that's when you start to get curved lines, V shapes, all kinds of other wonky things when you have a rate of change that's not constant. We are going to focus on rate of changes that are constant so that we can have straight lines. So we're going to look at these tables and we're going to determine which tables are linear and which tables are not linear. And the best way to do that is to see which ones have a constant rate of change. So we're going to determine the rate of change for each of these, and we're going to do that just by looking at the tables rather than, we're not going to worry about doing the full rate of change formula. I'm using air quotes here. Here, we're going to just look at just the tables here and look at what's happening in the table as it's changing from one point to the other. So focusing on the left side first, when we go from one row to the other, each of these is increasing by 1 unit. Going from 1 to 4, from 4 to 5, 5 to 6, 6 to 7. Each time is going up by 1. And if the right side, the y values, are all increasing or decreasing by the same number, by a constant rate, then we know that this is linear. So from 48 to 44, it's going down by 4. And then from 44 to 40, it's going down by 4. From 40 to 36 is down by 4. 36 to 32. 32 looks like all of these are going down by 1. All of these are going down by 4. And we know once again that these are a consistent rate of change, because if we take the change in y over the change in x, every time when we divide them, since the change in y, since the change in x is -4 and the change in y is 1, every time we divide them, we'll get -1 over 4. We'll get -4 over 1, giving us a constant rate of change. And so this is linear. On our left side for this next one, each time, once again, this is going up by 1. And so for this entire table, our change in x is going to be 1 for the entire table, because this is changing by 1 the whole time. So in order for this table to be linear, since my change in x is 1 the whole time, my change in y has to be the same number the entire time. So this is +1, and this is not +1, which means this, I don't even need to go any further because it's not linear. And once again, it's not linear because my change of x is consistent, but my change in y is not. Number 5, looking at x first. 9 to 10 is 1. 10 to 11, these are all changing by 1. So my change in x for all of these is 1. And once again, since my change in x is all the same, my change in y needs to be all the same. If it's not linear. If it is linear. So I will go ahead and test these all out. And the best way to do this is to subtract these numbers. So in your calculator, you'd want to do 23 and 56 hundredths minus 25 and 55 hundredths. And you'll see that it is decreasing by 1 and 99. And then you'll do the same thing for the next pair. You'll do 21 and 57 hundredths minus 23 and 56 hundredths. And you'll see that that one is also decreasing by 199. And some students might do these two and say, oh, they're the same. Let me stop. I'm done. You want to test them all out just in case. So we're going to go ahead and test them all out. And you will find that for this particular problem, they will all actually be the same number, which means that this is linear. And one thing I've noticed when doing this problem with students in person, they tend to look at this problem and try to manually do this addition or subtraction in their head, and they'll notice that 55 and 56 are different by 1, and then this number is different by 2, and they'll say that this changes by 2.01, and then they'll look at this, and they'll look at it, and the numbers will be off mentally. It might be helpful, especially if you're still working on adding and subtracting with decimals and negatives or whatever. It might be helpful to make sure you put that in a calculator, just to make sure you're not having any errors. This particular one, I tend to have students tell me it's not linear because of calculation errors. So you might want to double check that with a calculator just to be safe. And our last one here, we're going to look once again at the left side first. And I'm noticing here that from 2 to 4 is adding 2, but from 4 to 5 is adding 1. So this is not consistent as far as the change in x all being the same as the last 3. And so I can't just say the change in x is 1. So I'm going to go ahead and actually write out what my change in x's are this time. Because I will actually have to start calculating my rate of changes. And now I'm going to do the same for my change in y. From 62 to 74, the number is going up 12 because 74 minus 62 is 12. And from 74 to 80, it's going up 6. And from 80 to 86 is going up 6. From 86 to 110, it's going up 24. And from 110 to 140, it's going up 30. Now, students tend to look at this immediately and say, these are all different. These are all different. This is nonlinear. Now, yes, these are all different. Does that automatically make it nonlinear? No, because we're looking at the change. We are looking at the change in y over the change in x. We have not looked at the ratio of the change yet. We just looked at what are the changes of these? We now need to look at what are their ratios. So we need to look at the ratios of each of these. Are they the same? Which means that we need to divide them and see if when we divide them, will we get the same rate of change? And y is on top divided by the change in y divided by change in x. So here's the change in y, 12 divided by 2. Well, 12 divided by 2 is 6. And then we have 6 divided by 1, which is also 6. And then we have 6 divided by 1, which is also 6. And then 24 divided by 4, which is also 6. And then 30 divided by 5, which is also 6. So although the change in x and the change in y are all different, when we think about the rate of change, the ratio of the change in x with the change in y, their ratios, the change in x over the change in y, are all 6. They're all changing at the same rate, which means this is indeed linear. And that is how you find linear relations.